I have to have common bases, right? If I don't have common bases, whether it's for the exponentials or whether it's for the logs, I have to have common bases. But then you guys like the one-to-one property because he should be super easy, right? The inverse property, well, he's a bit more tricky, but remember, if we have something like log base a of x, if I have a to the power of that, it reduces just to the argument, just to x. And similarly, if I have log base a of a, once again, common bases. But if I have log base a of a to the x, then I'm going to have just the argument again. So we're going to start off right away in this section because we've done a lot of stuff with logarithms and exponentials. We're going to start off right away with some problems. Some of them are easier, some of them are harder. Technically, guys, in this whole chart, they were able to do each of these in one line and one line only, which was kind of like 2 steps. We're going to take maybe not all of them, but some of them. Some of the basic ones, some of the easier ones, and work our way up to the harder ones, okay? So, here we go. Letter A. Can I use the one-to-one property, the inverse property, or make up something? What should I do? One-to-one. Well, if I'm going to use one-to-one, what do I need? Common bases. So I'm thinking I should keep him, right? But maybe I should change 32. Guys, what is 32?
2 times 6. 4
Oh, 4 and 4. Sorry, I already started writing. So what's it going to be? 2 to the power of? Yep. Well, that was an easy one-to-one property because then I can just say x is 5. So I just factored them and I said, hey, okay, if I know the power of 5, I should say the power of 2, that makes it 32. Sweet, one-to-one done. How about letter B? Any ideas? What can I do with letter B?
You can move ln. Yeah.
Oh, that makes it way too easy, really? Yep. I'm going to show the easy way. In period 3, we totally did it the hard way. It still works, but it's a little bit trickier. So I can make it ln of x equals, you said just move it, right?
Yeah.
Now what?
Cancel out.
Not really cancel out, but according to my property, I can say the arguments must equal. So yeah, x equals 3. Is there another way that we could have done it? Did anybody think of any other properties? David? Quotient. Yeah, maybe I could combine them and say, all right, well, this one's harder, still possible, but harder. I could say ln of quotient property, x over 3 equals, now what? I can't go that way. Remember, if I have a quotient, it goes to subtraction, or subtraction goes to quotient. But I agree that you need to do something with the ln, but I can't distribute him. I would love to undo him, though.
Can you take make e the base?
Inverse of log. What is the inverse of log? Well, what's the inverse of ln? What's his base? E. So I could do, couldn't I?
Yeah.
E to the power of, e to the power of? Not e times, but e to the power of, e to the power of. Question, what's e to the power of ln of anything? Well, not 1, but the argument. Cancels out, I get x over 3. What's e to the 0? So then x equals, same dealio, right? But one used the one-to-one property after a little bit of moving, and the other one said, I need to get rid of ln's, they're in my way. All right, e to the, got rid of it, simplify. What relationship, just one more time, what relationship lets me do this and simplify to this? What's the relationship between e to the power of and ln of?
What's the question?
relationship between e to the power of and ln of that lets this simplify?
Oh, because
Crystal louder. They're inverses, so they undo each other. But yeah, George, I think you were getting there too. All right, how about these ones? How about these ones? Let's get a little bit more out there. Let me give you a second to write them down. I have 1/3 to the power of x, and I have e to the x. The 1/3 is kind of light, sorry. I have 1/3 to the power of x, and I have e to the x. 1/3 to the power of x and e to the x. I have two exponential equations. I need to solve for x. What can I do? 1-to-1 property or inverse property? What do you think? For this one, for C. George?
wouldn't it be easier to make it logarithmic form?
Maybe. I heard two, inverse and logarithmic are the same thing, right? So hold on, let's see if it makes it easier. If I was to go to logarithmic form, what would I take of both sides to undo? Log base,
1/3.
my base would be 1/3. Log base 1/3 of 1/3 to the x, and then log base 1/3. Well, it's not wrong, right? And what is log base 1/3 of 1/3? X. And log base 1/3. Is this an answer? Yes. Is it simplified? No. Well then, what else could we do? 1-to-1? Like maybe 1-to-1 instead? Then let's go ahead and let's rewrite him and say, well, we tried inverse. Let's see if 1-to-1 works. And guys, there actually is a way to keep going. I'll show that in a second. But wait, 1-to-1, what do I need though? Common bases, right? I can make him 3 squared. I should probably write this in red. I can make him 3 squared. What can I make on the left-hand side?
3 negative 1.
3 to the negative
Negative 1.
1. Why am I allowed to? Negative exponent is denominator, right? So I can make positive 3 to the negative 1, same thing as 1/3. What do I do if I have a power to a power? Yeah, no, you're right. Multiply. Negative 1 times x, negative x. Can I use the 1-to-1 property? Because negative x equals 2, so x equals... Wait, so is this the same thing as that? Yeah, but the way that you would have seen it, you would have had to change the base and say, I don't like 1/3, but there is a 3, and I see 9, and he's 3 squared, so maybe if I change the base to be log 3 of 9 over log 3 of 3 to the negative 1, then maybe I could have brought down the negative 1, brought down the 2, found negative 2, but it just would have taken a bit more creativity, right? It seems a little bit more confusing. So still possible. This does in fact still equal negative 2, but I think the 1-to-1 property might have been a little bit easier. George, go ahead.
Like in a test, would you look for, which answer would you look for?
Well, here's the problem. If it was a multiple choice, if you had an answer and it didn't match up with my answers, but one of my answers was more right, do you know what I mean?
Yeah.
So that's where it could be a dilemma. If it was a long answer, for the most part, unless I say something like fully simplify or simplify completely, if I didn't say that, then it'd be like, okay, you simplified, like you solved. It's a right answer. But if it's multiple choice, it's harder. All right, guys, how about part D? Maybe he's a little bit easier. Or maybe he's a little bit harder. What's going to do with part D? 1-to-1 property or inverse? I think inverse too, because can you write 7 as a power of e? Is e squared 7? E cubed? Square root? No idea. want to even try to rewrite these as the same base. I have no clue. So if I'm not going to rewrite them as the same base, what am I going to do to each side, guys? How do I use the inverse property? What's the inverse of e to the power of? So I'm going to take ln of one side and ln of. How is that helpful?
X equals ln 7.
Yeah, I can do it a couple ways. I can say bring down the x, ln of e is 1, or log base e of e to the x is just, they undo each other. So, I know it's not pretty, but that's the answer. It's the best I could do. ln of 7. It's the best I could do. ln of 7 is x. Right? So sometimes, guys, sometimes it is going to be better to be looking for one-to-one properties and say, I think I can make their bases the same, and then say, da-da, answer. But sometimes one-to-one property isn't going to cut it. I have to go another way. And the inverse property is one of those ways. Now, we're going to go ahead and, I think I might have 2 more examples. Let's see. We have one more. One more. Then we'll take a step back out of the equations, try to give ourselves a strategy, plan of action, how to solve these, and then we'll come back to harder ones. What do you guys think? One-to-one or inverse? Do we even want to think about how to make 4 a log? To make one-to-one? No. So one-to-one doesn't seem to fit. I don't have a log on one side and a log on the other, so I'm going to have to use the inverse. Now, what's the inverse of log base 3 of? 3 to the power of. Maybe if we write it like this, it'll make a little more sense. I cheat and I just do a big 3 and a big 3, but technically 3 to the power of, 3 to the power of. Now what? Well, 3 to the power of log base 3 just simplifies to be, how do you do 3 to the 4th real fast? Just a mental math trick. Instead of 3 times 3 times 3 times 3, I can say 3 times 3, 9, 3 times 3, 9, 9 times 9, 81. 3 to the 4th. Just a trick. 3 times 3, 3 times 3, 9 times 9. Got it. 3 to the 4th. All right, cool kids, let's go ahead and take a pause. Let's take a time out from our different examples. These have been more basic ones. You might be like, are you kidding me? Well, ones that just need, let me go back to my slide real quick. You don't need to write this down, but ones that just needed like a quick factoring and then I could use one-to-one, or a quick rearranging, I could use one-to-one, or a quick, well, maybe it wasn't so quick, but seeing this as a negative and then rearranging again. -1. Maybe a few needed inverses, but they were like one-step problems. But we're going to get into harder, so let's go ahead and write down a strategy. Strategy. What to do every time you see an equation with a logarithm or with an exponential. A number to a power of x or x's. Don't need to leave any spaces until the undo part. So if you're solving an equation, trying to find x, we usually try to get it as alone as possible. So we're going to try and get our log or our exponential as alone as possible. Move aside, move things to the other side that we can. But then we're going to get stuck with the exponential or the logarithmic expression. So either we're going to look to our one-to-one property, or we're going to look to undo whatever expression or whatever operation is trapping the variable. Is anybody still on number one? I wanted to zoom in. No? Let me zoom in. Okay. 4 undoing. All right. If I need to undo, go ahead and Ken, what's up?
Oh, I was gonna ask if you want to use this one.
Here, yes. Anywhere else, no.
Right.
So if you want, you could just write with logarithmic and then write with me, and then you'll know when to put. So with logarithmic, okay. If I had a logarithmic expression like log base A of x equals b, and I'm actually going to do this two different ways, because there are truly two different ways to undo this, okay? One way is to think of our inverse property and say, okay, I can take the inverse operation of log base A by saying, do you guys remember? A to the power of and A to the power of. Because A to the power of log base A of x is going to just be x, and then A to the power of b is just going to be A to the b. You know what, guys? That's the best way. I was thinking of the next one. That's the best way. Let's not even look at a different way. That's the best way. Because then you say, sweet, I got my argument, I got my variable out of the logarithm because I undid him. I can't divide by log, I can't add log, I can't subtract log. I need to say a to the power of log base a. Then it reduces. And now, well, I've just gotten x by itself. That's going to be a good day, right? But what if, instead of being given a logarithmic expression, what if I'm being given an exponential expression like a to the x equals b? This is the one that's going to have two different ways. Okay. How do I undo an exponential? Well, with exponential, I need to use logarithmic, right? Now my a is kind of crazy big. Hold on, that's a little too intense for me. How about you guys? Let's make it a normal a. So a to the x, a to the x. One way is to say, you know what? I need a common base. So I can say log base a of a to the x is equal to log base a of b. Can I do it to both sides? Oh yeah. And what happens if I have log base a of a to the x? What's it become? X equals log base a of b. And that's not bad. It's not bad. But I don't think it's greatest because I wrote a different way. And so the different way, or I could take one of my nicer logs like ln or like common log. And I could do that to both sides. Now, if I did that to both sides, well, what can I use in order to get that x out of the power? Is there a property I could use? Power property? What's power property tell me? If I have any log of an argument to an exponent, I can bring that exponent to the front. Does that help? Yeah. I just got the variable out of where he was trapped. He was trapped in a to the x, but now, well, now it's way better. So now I can say x is equal to ln of b all over ln of a. Question, guys. Is that illegal or is that just fine?
It's fine.
Why? How else could I have gotten from here to here or back again? What is this?
B minus LN.
Looks a lot like the change of base formula. So technically you could have just solved it this way and then said, oh, I can change the base if I need to, if it's too messy, ta-da! Or I could have just started off with a different logarithm all along and ended up with the same exact equivalent expression. So are these the same? Yes. Could it be log b over log a? Mm-hmm. Could it be log base c of b over log base c of a? I don't care. There are a lot of different ways of doing it. So you could just think of, ooh, common base, go. Or you could say, I don't care what log it is, let's use an easy one because then I can always bring down my power. Both ways work. Both ways work, guys. Okay, I want everybody to drop their pencil real quick, stand up. I want you to give someone, at least 3 people, high fives, go. Everybody pause. Everybody stand up, stand up, stand up. Give 3 people high fives. 3 people high fives. Nope, stand up, stand up, stand up. Give it, please, 3 people high fives. Ricky, did you get 3? Stretch, because there is half the class falling asleep, and I know it's a Friday. All right, shake it out just a little bit. Let's clap 5 times. Sit down. All right, let's go. We can't stop. We gotta keep going. You guys are so tired. You're making me tired, and now I'm getting bored. All right, come on. Come on, come on, come on. Huh. On what? This is a general model. So it's a general equation like, let me come back a bit. Do we do any like these? So if here's the first one we did. If I have a log and if I need to get to the x, I can do the inverse of log base 3 by saying 3 to the power of. And when I do that, I have the inverse relationship and I can say x, haha, and have an answer. Okay, I'm glad we're awake, but we need to now be focused and awake, not just goofing off and awake. Okay. Over here, I had e to the. Well, I didn't know how to do the one-to-one thing and get them with common bases, so it's like, what do? I have to undo the exponential, but I have to use a log. Because as soon as I take a log of both sides, then I can say, are we good now? As soon as I take a log of both sides, I can say power property, x comes down in front, or inverse property, same base, haha, x. It makes possible what I couldn't do otherwise. Does that kind of make sense? Are inverses of each other. So remember, what is ln? It's like taking log base e. ln is just log base e. We just gave it a really snazzy name and a symbol. So then what is log base e of e to the x? And what is log base e? So you could think of it that way too. Does that kind of make? Yeah. Sometimes it's just hard because ln, you're like, I know it's a log, but I can't see it. And so when you look at it this way, it's like, oh, okay. Maybe that'll make a little more sense. Do some practice. You can see better when the light's off, but you can't fall asleep on me. Here we go. All right, we got it solved. But the first one is easy because all I have to do is say, I can use the, got it, one-to-one property, which tells me, who said that? Enkem, was that you?
No.
It's okay. Answer. What do I do then?
Sorry, what?
LN.
LN. Sorry, my pen can do this.
Well, you could do ln, except if it's one-to-one property,
You could already.
I can already just, David, go ahead.
You can just put negative x squared equals negative 3x in this one.
Now, Enkem, would that be the same thing as if I took ln of an happen to ln of e to the, that stays, ln of e to the, so same thing. Just without, by seeing the one-to-one property, I saved myself a step. Now guys, we know what to do, right? It's a quadratic, so I need to get everything. So I can go ahead and move that over, and I have, and I know to solve a quadratic for its zeros, I need to, starts with an F and ends with an factor. So I have x, I have x, I have -4, I have +1. Good? So x equals. Can I have more than one answer? Of course. Should I maybe always quickly double check that it works? Yes, but quick review. What's the domain of e to the x or anything to the x? How far left, how far right?
Infinity.
So all reals, right? So is there anything that I could plug into an exponential and have it not work? No. But what's wrong with log? Uh-oh. How far left, how far right does he go?
1, 0.
He has to be greater than 0. It has to be from 0 to infinity. I can never actually hit 0 or be any negatives. This is how you might get an extraneous solution, which means a solution that the math says is good, but when I plug in, it's like, no, not possible. Do these work? Yes. Why? His is all real numbers. If I were to plug -1 into a log, that wouldn't work, because then it would not be in my domain. That's a homework help. Okay. How about this one, guys? What should I do first? Look at your steps. What's the very first thing you should always try in our steps? Isolate. That means to get by itself. Well, I'm trying to get him by himself because he's the part with the x, so I can just divide by 3, divide by 3. Mental mathers, what's 42 divided by 3? 14. 3 into 4 is 1. 1 left over, 12. 3 into 12 is 4. Oyalua, what do you think? How do we undo? That's 2 to the power.
Log 2.
Ooh. Log base 2? How'd you know 2?
I don't know, I just looked at my notes.
That's good. And you need them to have the, yeah. So when we had a to the x, we would say log base a. So if it's 2, then it's 2. What's log base 2 of 2 to the x? Is she right?
Yeah.
Booyah. Right? However, can someone tell me another way that could be written? How can I write log base 2 of 14 in another way? Like maybe a more common way or a more natural way?
2 to the power of x equals 4.
Well, but that goes back here and I don't know what x is. Remember your calculator has 2 basic logs. It's ln and it's log, and I told you ln is really important in calculus. So I'm saying log 2 is not bad, but it's kind of complicated. We could change the base. And we could have gotten that one from back in the very beginning, having taken ln of both sides instead of log base 2. Not that log base 2 was wrong, but if I had taken ln and ln, the x would have come down. I would have had this expression a little bit faster. But you were right, Oriolua, log base 2 is fine. But if they wanted me to do it in like a more natural or a more common log, we can just use our change of base formula. How about these ones? They might be so easy they're hard, or they might be so hard they're hard. What do you guys more like? What do I do with A?
E.
What about them?
Basic.
in the front of ln into.
In front and like down, right? To the power of and to the power of. So e to the power of ln and e squared. What happens with e to the ln of x? What happens to e squared? I got that. Not too bad, right? What's e squared? Don't worry about it. Just stop. It's the best we can do. If we try to like put in our calculators, we'll have decimals. That's no fun. How about b?
Cancel all of these things.
Kind of like canceling. We're using the one-to-one property. Unless you wanted to use the inverse, then you could cancel, right? 3 to the log base 3. But the one-to-one property does the same dealio, yeah? Keep going, find the x. Should only take 1 or 2 steps. I heard it. 2. Because then I get 4x equals 8 by subtracting and adding, and then I get x equals... Oh, these aren't too bad, right guys? Got a little bit harder, aka more like homework. Yeah, on the last one, I'll go back for just a second. Go ahead. Here to here or here to here? Does that make sense? Alright guys, here we go. These are from homework. These are homework exercises, not the ones assigned to you, but the ones that are practice. Alright, number 28. What do you guys think?
Divide by 8.
Divide by 8, because we're isolating, right? We want to get this by itself. He's an exponential. What do you think of
Log
NCAM?
base 3.
We could do log base 3. Could do ln, but you guys just aren't tracking with the liking ln thing. Alright. It's okay. We're trying. We'll keep trying. Log base 3 of both sides, right? You're trying to undo an exponential function, aren't you? Is it going to work? Looks good to me. Maybe not the prettiest in the world. Could always change his base to ln 5 over ln 3 or common log 5 over common log 3. But you are right. Now what?
Subtract 6.
Move 6, so minus 6, right? I wouldn't like how that's written. You guys know that, yeah? But hold on, pause. What else do we need to do anyway?
Change every single sign.
Yeah, I'm going to divide by a negative, which is multiplying by a negative, and I would say you should probably write him as 6 minus. Yeah? And if you were to want to change the base, just to make it easier to solve, remember, you can always make it log, well, common log, I like natural log better. He's better in calculus anyway. ln of 5 over ln of 3. They're the same thing, right? He's just written in that logarithmic form, and he's that change of base. Still logarithms, but the change of base formula. All right, kiddos, there are some more examples that we're going to be doing. That's especially tricky, this one. Ugh. We're going to do a few more examples, which is why this section is going to carry over to Monday. But for right now, you know this weekend what is expected of you, and I'm going to go ahead and get to pass back your tests. So, remember,